Growing up, I enjoyed watching the comedy shows starring Lucille Ball, from the early I Love Lucy to the spin-offs that followed. Little did I know that I'd use a scene from one of these shows decades later to help teach a concept in meteorology. In the episode in question, Lucy and her pal Ethel are working in a candy factory where they have to wrap pieces of candy as they move past on a conveyor belt. As the speed of the belt increases, hilarity ensues. And it's that conveyor belt idea that arises in meteorology when it comes to mid-latitude low-pressure systems. Now, the most common way to think about a low uses an air mass approach. A typical storm has a warm front extending to its east and a cold front to its south. And these fronts separate different air masses. The warmer and moister air, called maritime tropical, resides between the warm and cold front. This area is called the warm sector. Colder and drier air, called continental polar, comes in behind the cold front while also retreating to the north of the warm front. And this air mass model of a low has been around for more than 100 years. A different model was proposed in 1980 by Penn State professor Dr. Toby Carlson. He suggested visualizing a mid-latitude cyclone as a three-dimensional system of three distinct coiling air streams called conveyor belts. Now, the warm conveyor belt originates in the warm sector and transports warm, moist air northward, where it eventually rises up and over the colder air. We get a lot of rain and snow from this so-called overrunning. The cold conveyor belt originates in the cold air beneath the warm conveyor belt and snakes its way counterclockwise around the low. In the winter, this can help feed heavy snow bands to the northwest of the storm. And finally, the dry conveyor belt originates at high altitudes. It wraps in behind the cold front and sometimes creates a dry slot that cuts off precipitation. Last week's East Coast storm provided a great example of all three conveyor belts. They're easiest to see on infrared satellite imagery because it's tied to the temperature of the tops of clouds. Let me pause the animation at a particularly good frame. This was the evening of February 1st. Here, the warm conveyor belt is this corridor that contains some green, indicative of relatively tall and cold clouds. The dry conveyor belt shows up as this coiling stream of yellow, which tells us that the high levels of the atmosphere are relatively dry. And the cold conveyor is this zone of clouds arcing back to the west beneath the warm conveyor, in this case, right into Pennsylvania, helping to give the overall storm a comma-shaped appearance. Within that cold conveyor belt were some heavy snow bands that pushed Allentown's total above 27 inches, the second biggest snowstorm on record there. They won't be of that magnitude, but more potential storminess awaits in our extended forecast, which is coming up next.